time travel. It's a concept that has captivated the human imagination for centuries. The ability to journey through time, to witness historical events, or to glimpse into the future is a tantalizing prospect. But is time travel truly possible, or is it merely the stuff of science fiction? To answer this question, we must delve into the nature of time itself. Time, as we experience it, is linear. It flows from the past, through the present, and into the future. We remember the past, but we cannot change it. We experience the present, fleeting as it may be, and we anticipate the future, though it remains shrouded in uncertainty. But what if this perception of time is incomplete? What if time is not a river, but an ocean, with currents and eddies that could allow us to journey through its depths? The possibility of time travel is a topic that has been explored by scientists, philosophers, and science fiction writers alike. It is a concept that stretches the boundaries of our understanding of the universe and raises profound questions about our place within it. While the idea of time travel may seem fantastical, it is rooted in some of the most fundamental theories of modern physics. When we speak of time travel, we must distinguish between two distinct types of journeys: travel to the past and travel to the future. Traveling to the future is, in a sense, less problematic from a theoretical standpoint. According to Einstein's theory of special relativity, time is not absolute but is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving relative to one another. The faster an object moves, the slower time passes for it relative to a stationary observer. This phenomenon, known as time dilation, has been experimentally verified. Traveling to the past, however, presents a much greater challenge. It would seem to violate our intuitive understanding of causality, the principle that an effect cannot precede its cause. If we could travel to the past, we could potentially alter events that have already occurred, creating paradoxes that could unravel the very fabric of space-time. To understand how time travel might be possible, we must turn to the groundbreaking work of Albert Einstein. Einstein's theory of general relativity, published in 1915, revolutionized our understanding of gravity. According to general relativity, gravity is not a force in the classical sense, but rather a curvature of space-time caused by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. The bowling ball represents a massive object, like a star or a black hole. The trampoline represents space-time. The weight of the bowling ball causes the trampoline to sag, creating a curvature around it. This curvature is what we experience as gravity. Just as objects following the curve of the trampoline would be drawn towards the bowling ball, objects in space are drawn towards massive objects due to the curvature of space-time. Einstein's theory suggests that space-time can be warped and stretched. Could it be possible to warp space-time to such an extent that it loops back on itself, creating a closed, time-like curve? Such a curve, if it could be traversed, would allow an object to travel through time. The possibility of time travel, particularly travel to the past, raises a host of paradoxes and philosophical conundrums. One of the most famous is the grandfather paradox. Imagine a scenario in which a time traveler journeys to the past and kills their own grandfather before their parent was born. If the grandfather is dead, the time traveler would never have been born. But if the time traveler was never born, they could not have traveled back in time to kill their grandfather. This creates a logical contradiction, a paradox that seems to defy resolution. The grandfather paradox highlights the potential for causality violations if time travel were possible. Our understanding of the universe is built on the principle of cause and effect. If this principle can be violated, it calls into question the very foundations of physics and our ability to make sense of the world around us.